Welcome to the World Oil interview series on artificial intelligence in the energy industries, sponsored by Rockwell Automation. At Rockwell Automation, we're devoted to helping you achieve success. From the production to distribution of energy, we help industry leaders unlock performance, reduce risk, and drive smarter decisions. Whether you're optimizing production, enhancing safety, or navigating the future of industrial technology, our expertise is proven to deliver measurable outcomes. Together, we're powering transformation, enabling operational excellence, and building resilience for what's next. Because in the energy industry, success isn't just about what you do today. It's about what you're ready for tomorrow. And now on to the episode with your host, Global Energy Industry Development Manager, Greg Trostel.
Hello, and welcome to the second episode of World Oil's podcast series on artificial intelligence in the energy industry. I am indeed Greg Trostel, and in this series we're going to be exploring the very wide topic of artificial intelligence as it relates to the energy industry. Our intent is really to cover the basics of AI, but then get into a deeper dive on specific topics that AI will address. Specifically today, in this episode, we're going to take a look into how AI is viewed through the lens of an automation company, specifically Rockwell Automation. So as always, we welcome your input, your feedback on anything that we cover today. We're also open to hearing from individuals or companies that want to participate in this series. Especially if you have a particular area of expertise and you want to share that story with the global audience. So with that, let's jump right into episode number 2, and I'm pleased to be joined today by Mr. Jordan Reynolds. Hello, Jordan. How are you doing?
Hey, Greg. Great. Thanks for having me.
Good. Jordan is the Vice President of Artificial Intelligence and Autonomy for Rockwell, which I have to say is a really cool title. And so, Jordan, welcome. I guess we should start by just doing a quick introduction of yourself and maybe how you came to be in this role and maybe what the role means.
Yeah, absolutely. So Jordan Reynolds, I'm based in Austin, Texas. I've been in the role for about 2 years now. I actually came into Rockwell through an acquisition of a consulting and integration firm called Calypso. At Calypso, I led a practice that was like exclusively focused on industrial AI applications, right? So how to understand them, the design of them, the implementation of them, how they scale, the different use cases. So wide variety of topics ranging from things like model predictive control to predictive maintenance, the incorporation of neural network-based vision systems, optimization methodologies used in operations management, a lot of industrial AI content for a wide variety of industries. Heavy process and oil and gas are one of the kind of the earliest and most enthusiastic adopters of some of that technology. And my firm was acquired by Rockwell. I spent 3 years kind of helping with the integration of it, and then moved into a central corporate role as the VP of AI and Autonomy, really based on the acknowledgement that these emerging technologies are extremely relevant to any industrial automation company, but especially companies that focus on things like control and optimizing complex physical processes in a high scale production scenario. And we sort of acknowledged that we need to increasingly incorporate these disciplines into our portfolio, understand how they create value for customers, understand how we capture value as a business and how we scale it. And that's really the intended purpose of the team. Kind of incorporates a large applied R&D organization, and then a team that's sort of focused on our strategy, how we apply it across our portfolio and with our customers and so forth.
Right. Oh, fascinating. And like even through school in your early career, you were kind of always pointing in this direction, or is this kind of a turn in your career that was unexpected?
No, I've been like deeply interested in artificial intelligence since about 2009, right?
Wow.
So
It
was far too early for any relevance in the market. I mean, actually, funny enough, there were some early beginnings in heavy process spaces like oil and gas, chemical refinery, around topics like model predictive control, which have leveraged neural network architectures for a long time. Process control, believe it or not, is one of the earliest commercial applications of neural network technology. A lot of people don't know that, but if you look at if you go to Google patent and read about, the patent literature on the topic of neural network architectures, you'll see a lot of submissions from companies like DuPont and then even companies that ended up at Rockwell, like an organization called Pavilion that's been doing this since, the early 90s, even before email. I got interested in it a long time ago. I think that, to me, it was sort of the magic, if you will, associated with going from programming, right? And I was a software engineer, a computer programmer. And, what really hooked me is the realization that, with certain like very complex problems that are innately like computationally intractable, that cannot be programmed, either because just the extent of the logic is just too daunting to, formulate in like an if then else conditional logic construct, or they're extremely dynamic and constantly subject to change and adaptation. So the notion that learning and adaptation mechanisms could be leveraged instead of explicit programming was just extremely interesting to me. And I kind of first discovered this as an engineer working in the automotive space, trying to figure out how like different configurations of automotive components on a vehicle lead to things like harmonic excitation and the reliability of the vehicle, and attempting to solve those types of problems with rules and conditional logic, and realizing the limitations of it. And machine learning was sort of an emerging concept, well established in the academic literature, but not well established in the commercial space at that point in time. And when I first got exposed to it as a potential solution, I kind of knew that I'd be spending the rest of my life on that topic. I wouldn't be satisfied with anything else.
Right. That's very cool. And I hope the younger audience out there is kind of twigging to that and seeing how many different avenues your career can take when you're involved in this kind of in this kind of technology, right?
Yeah.
So when we talk about specifically your role within Rockwell, your team's role within Rockwell, and you look at kind of where the future is going, maybe what the next generation is going to be, does AI play a part in that? And if it does, is it a minor role? Do you see a significant role? What's your view on that?
I would say an integral role, right? An essential role, in terms of the definition of what we do, right? So, Rockwell, we're an automation company, right? So we're one of the biggest automation companies in the world. We automate, a significant percentage of the large-scale production processes in North America, and a sizable percentage globally. So, automation is our focus. Automation translates down to, things like how you control processes, how you translate sensory input into an optimal action recommendation, and then even, things like how you manage and plan and schedule a production process so that you have, the best production plan underway that's going to yield the economic results that you want. And AI, really, I mean, the most concrete and practical way to think about AI is a new discipline for automation, right? Most of the value of AI itself comes from its innate capabilities in automating complex processes that would normally require a lot of human labor and kind of extensive reasoning and decision making and so forth. So if you're one of the world's biggest automation companies, and you see this emerging new discipline that stands to change or dramatically improve the way that things are automated in general, that's going to be extremely interesting to you, right? And it's extremely interesting to our company, which is why we have this division now that focuses on AI and kind of the ultimate impact of AI, which is like the evolution of automation to autonomy, right?
Right.
So I think that's the significance of it. I think that products and capabilities and the things that we do for our customers are some of the most applicable applications for AI in the world economy, right? I mean, we create systems that sense, think, and act and adapt for the purpose of adapting complex processes. And these systems have to be explicitly programmed by engineers that sort of understand what needs to be done and how to do it. And that programming experience translates down to kind of fixed rule sets of conditional logic that are really the backbone of the world's manufacturing economy. And that logic either runs in kind of individual programmable logic controllers, or in the case of heavy process industries, running in distributed control systems, DCS environments, and things like that. And all of that is kind of rooted in the basic concept that somebody with an understanding of what this complex operation is supposed to do is going to be able to codify that understanding in programmable logic of some sort. And then it's just an aspect of executing that logic in real time to run an operation, right? So now you have these new sort of disciplines, forget the term AI for a second, but really just think of the substance of AI, which is learning and adaptation, right? So the ability to sort of induce an understanding of what needs to be done out of historical data, or induced out of simulation environments, for example, and then adapt those learnings as environmental conditions change dynamically. That's a transformational new discipline and kind of breakthrough in the topic of automation, right? And then, if you think about what these automation systems do for our customers, but for kind of the world in general, I mean, these things are essential for us to produce the things that we need to survive and thrive, right? So, in the context of this discussion, energy, and energy is more important than ever. But even beyond energy, food, clean water, mobility, personal care and comfort items, life-saving pharmaceutical therapies, right?
Right.
Our ability to kind of thrive as a global community is rooted in our access to these types of things. And if we are able to create more abundance of those things, we're all better off, right? So it has a really kind of powerful impact when you think about it at scale. And I'm most enthusiastic about just the way that we change how we think of automation in general with some of these emerging technologies.
Yeah, I love that phrase, a new discipline. I think it's the first time I've
Yeah.
heard that mentioned, but I really like that perspective on it for sure. As part of this, as part of the conversation, then when we look at your title and it says autonomy, right? That's often a big question, especially in the energy industry. Is are we really moving towards a potentially completely autonomous manufacturing environment? And because Rockwell touches so many different industries, what may be true in automotive or pharmaceuticals, but as we get into energy and these processes are inherently more dangerous, does that change your perspective? How do you see this whole idea of a potentially fully autonomous manufacturing operation?
Yeah, I think it's I think of it more as you rethink your human labor allocations towards things that are more creative and strategic in nature, like things that are sort of focused on defining what we are trying to accomplish, defining distinct objectives that need to be solved for, the constraints under which those objectives are achieved, and then being able to manage out to sort of oversee a greater scope of operations, as opposed to having people ingrained in every single stage of the production process, right? So
Right.
I think the role of people in the equation sort of changes. An analogy that I like to use is, if you think about an adjacent market like self-driving vehicles, like think Tesla and Waymo and some of this new mobility technology that's coming out. That it's really the translation of a driver to a passenger, right? The passenger is ultimately establishing the objectives. I want to get from this location to this destination, and maybe here are my preferences or the constraints under which my mobility plan is going to be executed. And the actual low level kind of supervisory and control level decisions on how that happens are automated in the vehicle, and the vehicle has the ability to perceive its environment, understand its state within the environment, understand kind of in a real-time control loop the manipulations that need to be made to the vehicle, like the steering angle and the speed and the brake and so forth, in order to get there. But the objectives are still defined by the human, right? And I think in manufacturing industries that will remain to be the case. There's nothing out there that indicates that high-level goals, objectives, and constraints can be creatively determined by AI capabilities. All of those are still explicitly defined by humans, even in the most advanced AI use cases today, really without any exceptions at all. So I just think it changes the way that humans collaborate with technology for the most part.
Right. Fantastic. The other big concern that we hear sometimes as we kind of look at the basics of AI in general is that ultimately the data is created or the directions are created by people. People have biases, and how do we, or sometimes just inaccurate? How do we approach that difficult topic with AI? The next generation, and trying to keep those biases or inaccuracies out of the
Yeah.
out of the program.
Yeah, no, that's fair. I mean, two biggest concerns out there are probably are we going to have massive labor reductions, human labor reductions in the
Right.
market, and then
Right.
if AI is trained with erroneous data or biased data, is the AI going to make decisions that are kind of rooted in those biases and things like that? Both of those are completely legitimate questions, and I think we're getting an increasing level of understanding about what the answer is. So just like on the first topic about human labor, you have to remember we've kind of as a society gone through several major technology inflection points since kind of the Industrial Revolution, right? So there was the first kind of this mechanical revolution where rather than operating as an agrarian society, we began to develop machines that could take in raw material inputs and produce finished good outputs. That was kind of the hallmark of the Industrial Revolution. From there, we had this electrification phase where now those mechanical machines become electromechanical machines, and the capabilities of production are much greater. Around the late 60s, we had this sort of emerging introduction of something called the computer. And then even in production scenarios, we started to see digitized or computerized production capabilities with the introduction of the programmable logic controller. So now you're not just linking together electromechanical relays or wiring sensors to actuators in an electromechanical system. Now you actually have the ability to sort of program logic that defines what your production system is going to do. And now we're kind of, coming to a new paradigm. And then, the rest of the market follows this same progression. You see the introduction of the personal computer, you see the internet, mobile devices, the cloud, and things like that. And there's commonalities in every one of those stages, right? One commonality is in each of those stages, everybody was concerned that the introduction of that technology was going to reduce overall employment. But in each of those phases, employment increased, right? And I think it's hard because nobody in the Industrial Revolution could ever conceive of the notion of a software engineer, right? You couldn't even conceive of such a thing, right? You're so contextually removed from the idea of that if you were to be asked the question, well, what are we going to be doing in the future? You can't really answer it. And so if you there's a tendency to kind of look at it from a microeconomic perspective where you're just wondering what a group of people are going to be doing in the future. But you actually have to look at it from a macroeconomic perspective, which is that labor is reallocated into all these new places. We now have tens of millions of software engineers and IT professionals, in addition to all the the clerical and support professionals that support those businesses.
Which didn't exist so many decades ago, right? Yeah.
Before. In the automation space in the U.S. alone, so we have about 3 million frontline workers and operators operating in the U.S. today. We have about 3.5 million people that work in the machine building space, the robotics space, and the automation space within the U.S. and North America, right?
Yeah.
So, but what people don't really perceive what they perceive is just the robot and the notion of the robot replacing the human, without an acknowledgement of the millions of humans that are behind the industry that creates the robots, right?
Exactly.
And if the argument is that AI will substantially reduce labor, you sort of have to ask the question why that hasn't happened in any other kind of corresponding inflection point in our history, right?
Yeah.
So that's the way that I look at it.
When you talk about those inflection points too, I was at a conference last week and I saw this amazing chart. It was how long does it take to get to 100 million users? And cell phones or the internet, it took 15 years before you finally hit 100 million users. Chat GPT, 3 months. That's how quickly it was immediately adopted by so many people. So you're right, the technology is just moving so fast. You can't predict even 5 years from now.
Yeah, exactly. And then, on the topic of data, I mean, it's absolutely true that machine learning works by learning representations of the data in its training corpus, right? And if those representations are either incomplete or inaccurate, you can essentially expect a machine learning process to produce erroneous recommendations or incomplete recommendations and so forth. Um, the way that I think that kind of translates to our space, there's sort of the concerns are rooted in the notion that what we're actually doing is learning from what human operators are doing today. And
Right.
if human operators are making mistakes, or if they're not taking the optimal course of action, we're just repeating that
Right.
flawed process, right?
Exactly.
And there's a lot of debate on the right technology solutions to that problem. But like in process industries, for example, like spaces like model predictive control have sort of long acknowledged that you actually don't learn from the behavior of human operators. You learn the system dynamics first, right? So you learn the way that a complex process or electromechanical system behaves according to its current state, an action that's taken in that current state, and then how the system transitions to a new state. This is what's called a dynamic process model. And most of the way that we apply AI today in this space is to learn those dynamic process models. And then what you have the ability to do is optimize over that dynamic process model to determine which actions yield the most optimal response or the most optimal long-term objective, right? And that way, you're only learning about the way that these complex systems behave. You're not constraining your learning by the decisions that humans have made in the past. But then you can compare your models with what humans have done, so that you can at least acknowledge the differences and decide if those differences are really extreme. Should there be some sort of a mitigation or an investigation into why, right? And
So
that's
no bias in the physics, I guess, is what you're saying, right?
no,
If you
it's more like incompleteness in the physics.
right,
That's more of
right,
the problem. Bias is a much bigger issue in things like HR systems, where you're sort of you're analyzing people, or things like facial recognition platforms and stuff
right.
like that.
Yep.
For us, the scope of AI is understanding the way that complex processes operate and complex electromechanical equipment responds to stimulus, and the way that sensory states translate to actions and things like that. And if you focus on it through that lens, it sort of it gives you a sense of how to address it.
Nice.
Where in other spaces, bias is a much harder problem to solve.
Right, right. So with that point, then, if we focus a little bit on Rockwell in particular, when you look at the potential future, what the next generation intelligence will be within Rockwell, one particular thing that excites you the most or captures your attention at the moment?
Yeah, there's it's hard to pick one. I mean, I'll maybe give you a few. I mean, the most core to us is sort of the notion of a control system adopting learning and adaptation characteristics as an integral function, right? So if you kind of look at the history of control systems, they've progressively adopted more and more disciplines, like methodologies for automation over time, right? So, simple discrete logic is one. Process modeling is another that's very, very common in oil and gas. Robotics motion control is another.
Definitely.
Safety mechanisms, batch process methodologies as well. So as we move forward, suddenly things like learning and adaptation become new disciplines. Well, the notion of a controller changes, right? And I think
Right.
that's
Right.
very interesting to a company like Rockwell. You have something like an adaptable learning controller that perceives its environment, programmatically determines what the optimal actions should be, is able to take those actions, is able to measure the response of the actions, and then adapt its control policies autonomously, right?
Right.
And
Right.
the consequence of that is that, one, the things that you can automate today, like if you take the whole scope of things that are possible to be automated today, you could probably automate those things faster and with more robustness, right? And get, greater control, higher throughput and yield. But it also opens us up to a whole new scope of problems that were never before automatable because they're computationally intractable, like that point that I made earlier. It's too difficult to program them with conditional rules. But now you actually have a opportunity to automate things that were never before automatable, right? And I think that is fundamentally the most exciting aspect of it for me. But there's other kind of adjacencies, like the way that design tools begin to evolve, right? So, for example, things like simulation engines, both kinematic and chemical simulation engines, which are both really popular in oil and gas. Those begin to evolve to incorporate AI capabilities, or maybe rather they're used as AI training gyms, right? They give AI capabilities the ability to learn and the ability to validate their behavior, right? So that's an exciting aspect of it.
Right.
We're already incorporating, transformer architectures like language models for PLC code generation, right? So, in the cases where you can still program explicit logic like structured text or ladder logic, it automates the programming experience for you.
Of course. Yeah.
There's the whole scope of maintenance, right? So being able to learn a normal condition profile of like a critical asset, and then detect deviations from that normal profile and understand what those deviations mean, right? Contextualize them to a known failure mode, and then even predict the time to failure, determine what corrective action is necessary, what work instructions are necessary to deliver that corrective action, what materials you need. That entire field of capability changes with these technologies. So
it's crazy. I mean, it's like peeling back an onion, right? Every time you peel back a new layer, there's more questions and more challenges and other things to address. Again, I think going back to that idea that ultimately we're not going to replace humans. We're just coming up with constantly new questions, right? For all of us to address. So, no, that's exciting. That's really exciting. Any other final thoughts as we look to close in terms of the Rockwell outlook? Anything else you wanted to mention?
No, it's an exciting kind of new movement right now, and I think it's in my opinion, it has like really dramatically re-energized the entire industry of automation right now, and kind of changed the way that we think about automation. We suddenly have these incredibly these interesting partnerships with players that we never even conceived of partnering or working with before, like from like Microsoft and AWS and NVIDIA, and these these organizations that are contributing to the AI space, either the compute or the cloud infrastructure, or the algorithmic methodologies and things like that. And then we're now incorporating completely new to the world capabilities that are AI native, like autonomous mobile robots that things that can't even exist without learning and adaptation functions in the perception layer and in the control layer, and sort of starting to see how these things are creating value and giving us kind of a sense of where automation is going in the future. It's a really exciting and rewarding space to be.
And I always kind of like to close with this thought too, with that excitement and potentially the revolution within the automation industry. Is that going to help us attract talent? Because it's always such a big issue to kind of constantly keep talent coming into the organization.
I'm glad you brought that up, because that actually maybe one of the most important aspects of this. There's I think a 2 or 3 million person labor shortage to demand in North America today.
Wow.
And talent attraction and talent retention are really critical problems for manufacturers, both in oil and gas and in other industries as well. I just toured the Austin Gigafactory, the Tesla Gigafactory yesterday, and saw the Cybertruck production line, and I was just taken aback at just how compelling and attractive these types of places to work are. At companies that are really leading the charge on incorporating these emerging technologies.
Yep.
I mean, like if you were to tell me, hey, you're going to put on a hard hat and safety glasses and kind of work in this type of space for the rest of your life, I would be perfectly fine with that. But I think that that's for a lot of people, that's a relatively new phenomenon, right? Like the way that people thought of manufacturing, between 2000 and 2020 was, oh yeah, this is we prefer to move into new spaces like software engineering and more interesting modern or contemporary industries and things like that. All of that is changing, and I think there's this renewed passion for the physical world, right?
Right.
And now that like AI is being incorporated into the physical world, sort of via automation systems and things like that, physical AI, industrial AI, it's completely changing the labor market dynamics. Young people are passionate about going back into the factory. The factories themselves are changing and just becoming more desirable places to work, like what I saw yesterday.
Right.
So I think that's a really important element of all of this.
Yeah, that's fascinating. That is fascinating. I think we're well out of time. Man, I hope everyone enjoyed this conversation as much as I did. I learned a lot, and Jordan, that was really, really good. Thanks again for jumping on and spending a little bit of time with us. And I'm assuming we'll have plenty of chances to talk in the future. I definitely want to thank Rockwell Automation not only for participating in this episode, but for sponsoring our whole first season. Definitely check out rockwellautomation.com, and I want to make a big pitch for Automation Fair, which is our premier customer event that's happening November 17th through 20th in Chicago, 2025. So it's a great environment, a great chance to come out, see some of the stuff that Jordan's been talking about, talk to Jordan and his team directly as well. So I highly encourage people's interest in that. So join me again on future episodes of AI and Energy, and hopefully we'll be just as exciting as this one was. And we'll be going into greater depth on some of the more specific topics around maybe cybersecurity, safety that Jordan was talking about, sustainability, things like that. So really appreciate everybody listening and watching, and take care.
Thanks, Greg. Appreciate it.
Thanks, Jordan.